fundamental theory of arithmetic, and this is just a few lines on here. So every natural number greater than 1 is either a prime or a product of primes, okay? That means any number, you can write it as a product of prime. Okay, say 6. 6 is 2 multiplied by 3. These are both prime numbers, okay? Say 36. Can you write this as a product of prime? 36 is what? 4 times 9, huh? 4 times 9, we can write it as 2 times 2 times 3 times 3, correct? We can write it as a product of prime numbers. So that is what this theory is saying. The fundamental theory of arithmetic says that any number can be written as the product of primes, and its prime factorization is unique. That means it has only one set of prime numbers like this. No other prime numbers, okay? Only one set. So that's why it is unique, okay? So the prime factors for 330 are 2, 3, 5, 11. These are all prime numbers. So 330, it can be written like this as a multiplication of all prime factors, okay? And this is unique. No other, it doesn't have any other set of prime numbers. So that is the fundamental theory of arithmetic. So you just need to remember these first two lines here, okay? That every natural number can be written as a product of primes, okay? Okay, so let's look at prime factorizations. What is prime factorization? In prime factorization, we factorize the numbers into prime numbers, okay? Any number, if we break it down into prime numbers, we call that prime factorization. Factorization is when you write a number as a multiplication of its factors, okay? Prime factorization is made up of only prime numbers that multiply together to result in the original number. In other words, when you multiply the prime factors of a number, it must equal that number, okay? Prime factorization can be written using exponents and must go in numerical order. That means from small to bigger. Okay, you will understand this better when we do the examples. Okay, so there are two methods of, I'm sorry for all these things, okay? There are two methods of prime factorizations, okay? The first method is the division method and the second method is the factor tree method, okay? So we're going to look at the first method, first division method. Although this method is easy, it is sometimes time consuming, okay? So to do the division method, okay, you divide by the smallest prime number, okay? Okay, I'm going to do some examples here. Say we're going to look at 56, okay? We're going to do the prime factorization for 56. That means we want to break this number down and write it as a product of prime factors. How do we do that? We do long division, upside down division, okay, like this. 56. We always start with the smallest prime number. We start by dividing with the smallest prime number. In this case, the smallest prime number is 2. You know that, but we must divide evenly, no remainders. So 56 divided by 2 is 28. Can 28 divide by 2? Can,
Yes.
Can divide by 2, so divide. We only can divide by prime numbers, okay? So 28 divided by 2 is 14. 14 can divide by 2? Yes. So it is 7. And 7 is a prime number. So when we reach a prime number here, we stop. So our answer is this one. This is our answer. So 56 is equals to 2 multiplied by 2 multiplied by 2 multiplied by 7. Okay? But the best way of writing it is 1, 2, 3, where 2 to the power of 3. This is what we call exponent. 2 to the power of 3, or 2 exponent 3 times 7. So we have written 56 as a product of prime numbers. And this process is called prime factorization. This is method 1, okay? Okay, you try this. 1050 divided, okay, you find for me. You do the prime factorization and tell me what are the prime factors. I have 2 questions for you, okay? Finish?
Number one, famous.
Okay, the first one. What are the factors? What do you divide by first? You divided by 2, huh?
Two.
So did you get 5 to 5 here?
Yes.
So can you divide 5 to 5 by 2? Evenly,
No.
cannot, yeah? So you divide by
Five.
the next smallest prime number. You always must go from the smallest to the biggest, huh? So the next smallest prime number is, can you divide by 3? Can you, some of you divide by 5 straight away, eh? Can you divide by 3?
Yes.
Can, so you get 175. Remember, you must always divide by the smallest prime number. Okay, so this one, can you divide by 3? Cannot. So the next prime number is 5. Divide by 5, you get 35. Divide by 5 again, you get 7. 7 is already a prime number. Therefore, so this is equals to 2 times 3 times 5 times 5 times 7. So we can write this as 2 times 3. Always write in numerical order, that means from small to big, times 5 to the power of 2 times 7. Okay, so this is your answer. Correct? Everybody got that?
Yes.
Okay, 1092 divided by 2, you get 546, correct?
Yes.
6 can divide by 2 also. So we
Yes.
divide again, we got 273.
Three.
Now divide by
Three.
3.
3. Yes, divide by 3, we have 91.
91.
91 divided by 3 cannot read. So 5 cannot. The next number is
7.
7.
7.
So you have 13. 13 is already a prime number, so we can stop here. So this is 2 times 2 times 3 times 7 times 13. So it is 2 to the power of 3 times 3 times 7 times 13. Okay. So this is, so we have broken down the number into its prime factors. Okay, this is called prime factorization. This is the first method, long division. Okay, so we're going on to the second method, that is factor trees. Okay, we're going to use a factor tree to find the prime factors. Okay, so number one, example one, okay? Find the prime factorization for 24. So we're going to do this. This is our factor tree, the branches. So 24 is 4 multiplied by 6, or we can use like this. 24 is 2 multiplied by 12. This is the first, we start with the first 2 branches. We can do this way, or we can choose anything. We can start with any factors, okay? So say we say 24 is the first branch is 4 times 6 will give you 24. And then now break down 4. What are the factors for 4? 2 and 2. This is a prime number, so can stop. This branch can stop. This is the prime number, this branch can stop. So 6 factors for 6 is 2 times 3 will give you 6. This is prime number, this is prime number. When all the ends are prime numbers, you can stop. So from here, you know that 24 is equals to 2 times 2 times 2 times 3. Okay? Or you can do like this, 2 times 12. 2 is already a prime number. You can stop. Okay? It's okay if you don't continue this line, or you can continue so that you don't forget these two. Okay? This is 12. So 12, break it down into its factors. 2 times 6. 2 already prime number already. So you just copy back only. Just copy back. Here 6, break it down again until it reaches prime number. So check that all the ends are all prime numbers. So you have stopped. Okay? Some people only do like this. Until here. Some people only do like this. Like this is also okay. But some people like to bring it at the same level so that they don't forget any numbers. Okay? So we write 24 as 2 multiplied by 2 multiplied by 2 multiplied by 3. This is 2 to the power 3 multiplied by 3. This is called a factor 3. Okay? Okay. Example 2, what is the prime factorization for 36? Okay? So 36 is 3 times multiplied by 12. Or we can use 6 multiplied by 6. Or we can use 9 multiplied by 4. Doesn't matter what you start with. You can start with any two factors. So the original number is 36. Factors for 36 is 9 and 4. So 4, break it down again. Factors 2 and 2. So this one can stop. 9. Break it down, 3 times 3 is 9. All 4 numbers are prime numbers, so we can stop. So 36 is equals to 2. Remember, we must write the 2 first, small number first. 2 times 2 times 3 times 3, or 2 to the power of 2 multiplied by 3 to the power of 2. Okay, so this is called the factor tree. So you can use either one to do your prime factorization. Okay. Okay. So you want to find the you want to find the prime factorization of 228 using the factor tree. Okay, you try first. Okay, so what did you get?
2 times 2 times 3 times 19.
Okay, very good. Okay, so for those of you, if you haven't got that, you can use any way. So maybe you have two different factors here, okay? So this is mine, okay? So I have got a prime number here. I'm going to, this branch will stop, okay? So now I'm continuing with 114. Say I have 2 times 57, huh? 2 times 57 is 114, okay? So this also, this branch already reached a prime number, already stopped. So 57, I can factorize it some more, 3 times 19. Prime number, prime number. Therefore, 228 is equals to 2 multiplied by 2 times 3 times 19. Huh? So 2 to the power of 2 times 3 times 19, okay? Remember to write your answer like that in the end. Okay. Say if you want to do another question. Huh? Okay, another question. Huh? Say I have 300. Huh? Say I have 300 here. And I want to do prime factorization using the factor tree. So what factors can I use? Can I use 30 times 10? I can use 30 times 10. Huh? So I break this down. I have 2 and 5. These are both prime numbers. Huh? This one here, I break it down to 5 and 6. This is a prime number. This is not a prime number. So I'm going to break 6 down to 2 and 3. So these two is prime numbers. I can write this here, bring it down here, 5, bring it down here, 5. I can do it like this. Huh? So 300 is equals to 2 multiplied by 2 multiplied by 3 times 5 times 5 equals to 2 to the power of 2 times 3 times 5 to the power of 2. Okay, so you may start with any other. You can even start with 2 times 150, 300. So it doesn't matter how your factor tree starts, okay? As long as the last row, they are all prime numbers, and you get your correct answer. So this is prime factorization, okay? So we have already looked at both the methods. Huh? Okay, the first method is with doing division.